Example problem 5-37. A link containing points A, B is to assume the positions listed in the table for each problem. Graphically find the location of the two fixed pivots and the lengths of all four links of the mechanism with a coupler that will exhibit the motion listed. Also determine the amount that the pivot links must be rotated to move the coupler from position 1 to position 2. So we're doing two position synthesis of the coupler of a 4-bar mechanism. So what we're looking to find is what two grounding points that our two rotating links need to be for our coupler to move from this location to this location. So what we're going to start by doing here is we're going to draw a length between A and A prime, as well as a line from B to B prime. Now we need to construct some perpendicular bisectors. Again, a perpendicular bisector is a line at the midpoint that is perpendicular to the point between the two. So what I've done is I've arbitrarily chosen, actually let's make this 3 as well. I've arbitrarily chosen the length of 3. Now since we're choosing 2 points, we can make these as long as we want. The only thing is that our grounding point that connects to point A and our grounding point that connects to point B has to fall along this line somewhere here. It could be all the way down here. It could be up here. Again, these are design considerations that we get to choose. Some are better than others, but for this problem, it's fairly arbitrary. So let's just go ahead and let's make them where these lines have ended up at. So let's draw first our original configuration in white, like so. And let's actually go ahead and let's just show our frame points a little better here. Bit of a excessive frame point there, but it is what it is. There we have it. There we have our 2 frame points. Let's go ahead and we'll draw our second configuration. Again, from these frame points, and so there we see that our coupler is able to rotate from its original position to this A prime B prime position if we choose these 2 locations here. And again, these 2 locations could have been anywhere along these perpendicular bisecting lines. So let's go ahead and let's find our locations for these 2 points. We can do that by using the location function in AutoCAD. We choose this one, and we find its location to be negative 0.1818 and 0.145. This location to be 1.42, 1.59. And again, let's write this in an annotation when you're doing this in your problems. I want to see those locations as well. is see how far these lengths have rotated. We can go ahead and make that a little more precise. They rotate 58 degrees as this coupler moves from AB to A prime B prime.